In the realm of industrial automation, a leading multinational corporation has demonstrated significant revenue growth, despite global uncertainties. The company reported an increase in sales revenue by 5% compared to the previous year, nearing €79 billion. This impressive performance highlights the critical role that industrial automation plays in driving business success. The subsidiary in a Central European country also showed an 8% rise in sales revenue over the same period. The CEO of this subsidiary emphasized the importance of automation and energy distribution in the current business landscape. Industrial automation involves the use of advanced technologies to control and optimize manufacturing processes. One of the key components in this domain is the Programmable Logic Controller (PLC), a specialized computer used for industrial control applications. PLCs are essential for automating processes, enhancing efficiency, and reducing human error. Imagine a factory floor bustling with activity, machines humming in perfect synchronization. At the core of this orchestrated efficiency lies the Programmable Logic Controller, or PLC. This specialized computer is the unsung hero of industrial automation, orchestrating complex processes with precision. Unlike general-purpose computers, PLCs are designed to withstand harsh industrial environments, ensuring reliability and longevity. They operate in real time, making split-second decisions that optimize production lines. The PLC's role is pivotal. It automates tasks, reduces human error, and enhances overall efficiency. Engineers program these PLCs using sophisticated software like the Totally Integrated Automation Portal, which we'll delve into later. For now, understand that the PLC is the heartbeat of industrial automation, driving growth and innovation in manufacturing. To program these PLCs, engineers use software tools such as the Totally Integrated Automation, or TIA, Portal. This platform allows for the seamless integration of various automation components, providing a unified environment for programming, configuring, and diagnosing PLC systems. Imagine the TIA Portal as the command center of your automation ecosystem. It streamlines the process of developing and maintaining automated systems, making it a vital tool for modern industrial engineers. The TIA Portal's architecture is designed to handle complex automation tasks efficiently, allowing you to focus on optimizing your processes rather than troubleshooting software issues. By utilizing the TIA Portal, you can ensure that your automation components work in harmony, leading to increased efficiency and reduced downtime. Now, let's delve into configuring PLC systems using the TIA Portal. Begin by launching the TIA Portal software. Navigate to the Hardware tab and select Add New Device. Choose your specific PLC model from the list. Next, go to the Devices and Networks view. Here, you'll configure the PLC parameters. Set the IP address, subnet mask, and gateway according to your network requirements. Ensure the rack and slot settings match your hardware configuration. Under the Properties tab, fine-tune settings like the cyclic update time and diagnostics level. Remember, setting the cyclic update time to 50 milliseconds can significantly enhance real-time performance. For troubleshooting, enable the extended diagnostics option to get detailed error logs. This meticulous configuration ensures your PLC operates efficiently within your automated system. Now, let's dive into the execution phase of PLC programming. When you write PLC code, you're essentially creating a set of instructions that the PLC will follow to control industrial processes. This code is typically written in languages like ladder logic, structured text, or function block diagram. Once your code is written, the PLC compiles it into machine-readable instructions. The PLC then executes these instructions in a continuous loop, constantly monitoring inputs and adjusting outputs accordingly. For wiring, imagine the PLC as the central hub. Each input and output is connected to specific terminals on the PLC. These connections are crucial because they allow the PLC to interact with the physical world. For instance, a sensor might be connected to an input terminal, while a motor might be connected to an output terminal. The PLC reads data from the sensor and, based on your programmed logic, sends signals to the motor to perform actions. Remember, Precise wiring and correct code logic are vital for the seamless operation of automated systems. Optimizing PLC performance is crucial for maximizing efficiency in industrial automation. Start by fine-tuning the scan cycle. A shorter scan cycle reduces latency and increases throughput. Set the scan cycle time to 20 milliseconds for high-speed applications. Next, utilize efficient coding practices. Use structured text, ST, for complex logic and ladder logic for simpler tasks. Minimize the use of global variables to reduce memory overhead. Implement error handling routines to catch and log errors without stopping the entire process. Consider using interrupt-driven programming for time-critical operations. This allows the PLC to handle urgent tasks without waiting for the main program loop. Lastly, regularly update the PLC firmware to benefit from the latest optimizations and bug fixes. Remember, every millisecond counts in high-speed manufacturing environments. Now, let's dive into debugging common PLC issues and pitfalls. The first issue you'll often encounter is communication errors. These usually stem from incorrect baud rates or faulty cables. To resolve this, verify the baud rate settings in both the PLC and your programming device. Ensure it's set to 19,200 for most legacy systems. Next, check the cables for any signs of wear or damage. Another frequent problem is memory overflow. This happens when your program exceeds the PLC's memory capacity. To avoid this, optimize your code by removing unnecessary variables and using efficient programming techniques. For instance, use bit shifting instead of multiplication where possible. Lastly, don't overlook the importance of regular firmware updates. Outdated firmware can lead to compatibility issues and security vulnerabilities. Make it a habit to check for updates every quarter. Remember, thorough debugging not only ensures smooth operations but also extends the lifespan of your PLC systems. To conclude, let's recap the essential steps for achieving automation success. First, understand the critical role of industrial automation in driving business growth. Second, invest in advanced technologies like PLCs and platforms such as the TIA Portal. Third, focus on programming efficiency and system integration. Fourth, continuously optimize processes to enhance productivity and reduce errors. Lastly, stay updated with the latest automation trends and tools. By following these steps, you'll not only improve current operations but also secure a competitive edge for future growth. Remember, this knowledge is yours for free. Subscribe to our channel for more in-depth insights and continue your journey towards mastering industrial automation.